My name is Toph Whitmore. I'm the VP of Marketing here at Simba Technologies, and I'm pleased that you've joined us today. Our webinar today is titled Apache Drill in the Real World, How to Elevate Your Analytics with Apache Drill on MapR, SAP Lumira, and at Simba Technologies ODBC connectivity. Today we'll be hearing from three thought leaders in the space. Nitin Bandagula, Senior Product Manager of MapR Technologies. He's going to provide an overview of Apache Drill, specifically differentiating it against other data sources out there. Our second speaker will be Angela Harvey. She's the Director of Solution Management for Big Data and Analytics at SAP. She's going to show SAP Lumira and talk trusted data discovery as it relates to Drill. And then finally, we'll get a demo from my colleague Kyle Porter. He's the Senior Sales Engineer here at Simba Technologies, and he'll put Drill and Lumira through their paces. One administrative note, if you have any questions, please provide them to us via the Q&A chat window in GoToWebinar. With that, let me hand it over to Nitin Bandagula to begin. Nitin?
Thanks, Toph. Hello, everyone. My name is Nitin Bandagula, and I work in the product group here at MapR Technologies, and I focus on the open source technologies here at MapR. I'm excited to be part of the panel here to talk about the combination of Apache Drill, SAP Lumira, and Simba ODBC drivers that can bring unprecedented SQL access to big data. So here's what we have for you today. So I'm going to quickly cover the Apache Drill introduction and take you through some of the technical aspects of how Drill is different from other SQL engines. Then I'll talk about briefly the BI use cases that Drill enables. Then I'll hand it over to Angela, who's going to talk about SAP Lumira, and then Kyle here will make sure that we get a good sense of how these things work together through a great demo. So let's get started. So what's the motivation for Drill? So we know that data is doubling every 2 years. But what's important to note is that this data is mostly going to be unstructured and semi-structured in nature. So we anticipate that by 2020, it's going to be in the zettabyte range, and it's going to be an exponential increase in the volume and variety of data. However, you have to notice that the IT resources are actually not growing exponentially. We still have a small linear growth, and therein lies the problem. So how are we going to get to our newer data sources with the same level of IT resources we have? So what's interesting to note here is that we have built, so the open source community has built a lot of non-relational data sources where you don't have to worry about building a schema before you write data to a data store. So you have things such as HBase and MongoDB and Hadoop, which lets you store data without defining any schemas up front. And we're moving to a phase where most of the schemas are governed by applications and not necessarily centralized IT or DBAs. So we're getting to the point where you're able to process and store structured and semi-structured data easily. But what happens when it comes to SQL? We're still stuck in the phase where even if you're writing something to Hadoop without any schemas, the moment you have to provide SQL analytics on top of those data sets, you have to first go and define a schema somewhere in a Hive metastore or any other central repository that you'd like, right? So you now get down to situations where there's a lot of pressure on the IT systems to go and deliver these schema definitions, do all the ETL processing that needs to be done much, much faster. So how do we fix this scenario, right? So there's certain things that you would want to preserve from the traditional world, which is the ANSI SQL standards, because everybody understands them, everybody uses them on a daily basis. All the BI layer that we've developed over the last 20, 30 years use ANSI SQL, so all of those BI technologies should be able to use big data as well. Obviously, we're talking about low latency speeds where there's interactive speeds between what the user does and then what the results are. The results are essentially expected within a few seconds, from like 2 to 10 seconds, so people can interact with the data. So the interactivity is more important because Hadoop already provides something known as Apache Hive, which is for long-running SQL jobs. So you're looking for that interactive speed, right? But then on the right-hand side, you still want the agility and the flexibility where you could process that information faster. You could get your data as quickly as possible, because one of the big advantages of big data processing is getting to near real-time insights. Whether it's clickstream data, whether it's social media data, you would want to, or sensor data in the IoT space, you would want to get your data insights as quickly as possible. So that's where Apache Drill comes in. And the premise here is that Drill is the first schema-free SQL engine for big data. What do we mean by that? The Drill is the first engine that says, I don't want to deal with schema preparation first. I don't want to enforce or force people to go and create schemas. I'll start discovering. The engine will start discovering the schema for the end user versus the end user doing it himself. So now we're looking at a situation where you've written your data into Hadoop without any schemas, and when you're reading, the engine takes care of reading the data without any schema. So you're in a schema-free world where you're exactly getting what you want from your big data, faster insights and the capability to process large scales and varieties of data, right? So let's look at Drill in more detail here. So the first thing that Drill allows you to do is it lets you process structured data that comes from your OLTP systems, as well as semi-structured data that comes from your web applications or any other sensor applications that you have in your organization, right? So all of that can be put together on Hadoop, and you could process that information easily using Drill. The second one, Drill does not require, it's not a different database. Drill runs directly on top of Hadoop. So wherever the data is sitting, residing, your Drill bit or your Drill engine instance is running local to that data. So you get the MPP characteristics, and you don't have to move massive amounts of data across systems. Like I mentioned, there's no schemas required, so Drill does its own schema discovery on the fly, so you can get to your data faster. Drill is also very easy to use. I mean, you can actually download the Drill packages onto your laptop, point to a specific JSON file or a spreadsheet on your laptop, and start querying within a few minutes. There'll be some links that I'll share at the end where you could get to those links and start trying it out if you're interested. The third one is Drill is the first big data SQL engine which is based on ANSI SQL. So we started off with the premise that, okay, ANSI SQL is what we want for the end user. We don't want to go for a subset like HiveQL, which is what every other engine out there uses. Go with ANSI SQL because that will allow minimum learning curve for our end users or the SQL users, and it will also make sure that the BI tools, there's hundreds of tools out there, query builders and all kinds of SQL analytics tools can seamlessly integrate with big data. Right, so that was another premise there. But obviously, since it's a big data solution, there is scale involved. So Drill should be able to process petabytes of scale, thousands of users, and on data sitting on thousands of nodes. So that is a given. It has to work and provide the interactive speed. What's also important in the BI space is the granular security that you would require to enforce the right level of authorization and authentication. And I have a slide here which is going to talk about it. Drill has come up with a unique way of providing that decentralized security module, so you can actually have a departmental user like an SAP Lumira user or any other BI tool user work with a centralized IT platform where Apache Hadoop is generally deployed and still get that security in place without going through too many hoops. Right, so that's how Drill differentiates itself in the market. What it enables for the end user is what we term as it happens business. So if you look at the traditional approach, the governed approach, you would typically put your data in Hadoop, then you would evolve that data set, you would do some sort of a data modeling, then you would perhaps transform it to look like, to pick up the right columns and rows, and then typically would move it out to a different appliance, a different data warehouse, so you could run the faster analytics. But the total time of insight for that scenario typically runs from a few weeks to sometimes months even, because it takes time to process all of this information. You have to prioritize with IT. There's a lot of elapsed time, even if the actual work is less. But now we're saying there's another approach to big data analysis where you could actually explore your data instantly using Drill. So the Hadoop data sits where it is. The end users have access to that data through their regular BI tools, through their ODBC connectivity, and they can get to their insights, explore what that information is, understand that there's a specific data set which is interesting or not. It's more important to sometimes discard data than to get data, right? So to spend those cycles upfront much faster without requiring IT anywhere, right? Once you've gotten that insights, once you understand what those joins are, what those data sets are, then you could go to a scenario where you go back and tell your IT team, okay, this is what I need. these are the different fields that I want to get converted. Maybe we should convert it into Parquet because it runs faster on Apache Hadoop. Get that IT team involved only when you're ready for that monthly report that needs to get generated, right? So this is where we believe it's going to be a game changer for the industry because we're redefining how big data is looked at from a BI user standpoint. All right, so what it entails for the business at large is a net new use case. So we know that since the 80s we've had IT-driven BI where IT was completely in charge of how and when and what gets created in terms of BI reports. Then in the 2000s there was a lot of great innovation around self-service BI where the analysts were able to get to newer data sets without heavily relying on IT because they were simpler data sets. But then when it was context data, they still had to go back to IT to get some schema definitions down and some ETL work done. With Drill, we are now entering an era where there's a new set of use cases, a net new set of use cases that is augmenting your existing environment. So you could do schema-free data exploration. The analyst has complete control. He's still not relying on the IT guys for any ETL or schema definitions. He does what he needs to do in terms of exploration. It's big data. There's a lot of new data sets, a lot of volumes. Once he does that, then he switches back to the other modes to make sure that the organization gets what it needs at the end of the day. Right. So that's the net new use case that we are seeing in the market in terms of how Drill is getting adopted. So the business, as you can see, are twofold now. So for one set of users, who are the business analysts, the data scientists, we provide instant access to big data using existing tools. So the end users do not need to know anything about Hadoop. They do not need to understand HiveQL. All they need to know is I've got a tool that I have been using for years and I know SQL. Right? So these two skill sets, that's all they need. They're now able to process anything and everything that's being put on the Hadoop platform using the same tools that they've been using. And this gives them the power to get to their newer data sets much, much faster and come up with insights much, much faster. So your Monday morning meetings don't have to wait for like 2 months before you actually get the right insight. You can actually go on Friday, look at what that data is, come up with newer insights and newer intuitions, and be ready for Monday morning in terms of what you're looking at for your newer data sets that you have in your organization. So it's a great tool. People are loving it when they have access to especially JSON data because it's extremely difficult to process such data sets, especially when they are deeply nested and one row doesn't look like another row. So that's one use case or one benefit for one set of users, right? The other set of users are the IT shops, the enterprise architects who are in charge of the single source of truth. The organization has got so much data sitting in so many places. They want to merge all of those data silos into one place, get everything together. Now with Drill, they have that option of putting everything in Hadoop, but also provide the flexibility that these new self-service BI tools are used for in the market by the end user, right? So the adoption curve for Hadoop is increasing because now you are bringing Hadoop to the original user, the original SQL user, the guy who's been using data analysis forever now, right? Now they don't have to write Java code to get to Hadoop data. They can use existing tools together. So existing tools together with Hadoop, and they don't have to learn anything in the process, right? So obviously Hadoop is not as expensive as other systems, so you could leverage the scale and the commodity servers, if you will, to get get to value much faster and much cheaper than other systems. But you're also enabling newer data sets and newer kinds of analytics for your end users within the organization. So because of this flexibility, because of the fact that you're able to provide that flexibility for the end user, Drill has been recognized as one of the best SQL and Hadoop technologies. And since MapR packages the Apache Drill as part of its Hadoop distribution, we've been recognized as the top ranked SQL and Hadoop distribution. So the idea here, once again, is for newer data sets, for big data where there is a lot of complex semi-structured data being generated on a daily basis, on a second basis sometimes when it comes to sensor data, you need an engine which lets you process that information much faster than what we are typically used to even in our Hadoop environments today. So now I'm going to spend a few slides, there's about 4-5 slides I have, which goes at a very high level the technical details of what Drill's engine is, what the design center is. There's a lot more information available online on the Apache Drill website. I can provide the link at there's a link at the end of the webinar. You can go through that. But let's get started with the basic premise. Like I mentioned, the very first thing, the very first design center concept or paradigm shift is the schema discovery on the fly. So Drill is the first engine which it picks up the first 50 records, understands what the schema is, sends the results back to the end user, picks up the next 50, and then goes on doing this in memory while it's producing results for the end user. So you can work on semi-structured data, structured data. If you have, let's say, Hive metastore definition somewhere already, Drill is going to use that information. It's not going to say, no, I don't want it. It can very well use metadata definitions if they're already available, and get that insights much faster. The second one is, this is sort of the key differentiation when it comes to the internal workings of how Drill is built. So if you look at this chart on the left-hand side, there's flat data and there's schema data, right? So there is if you go across from left to right, JSON and JSON are data format which are most dynamic in nature, which means that no two rows look like each other, and there's context because there could be a lot of hierarchies within that. It could be nested hierarchies in there. That's the most complex form of data that we have today. And the most simplest form is the comma-separated file or an Excel spreadsheet. The way other engines are built today, just because it's relational mathematics, is everything is first converted to look like a table first, right? So it's all flattened out. Everything is a name. Everything looks like a table at the end of the day. So you are forced to consider converting all of those flexible nested data types to look like a table. And that takes a lot of time. Drill, on the other hand, takes the premise that, okay, everything is going to be only a simpler form of the most complex form. So I'm going to build a Drill engine. I'm going to build an engine which is going to be optimized for the most complex form, which is that JSON document form. So internal representation of a Drill table actually looks like a JSON document. And every other format out there, the CSV file, the HBase, the Parquets, they're all just a special, simpler form of that most complex form, and then the engine is optimized to deliver interactive speeds for the most complex form, so everything else falls in place when it comes to the simpler data format. Right, so this is a remarkable difference in how Drill looks at the data sets and how it actually does the schema discovery on the fly much faster than any other engine out there. The third concept here is Drill is made to be extremely flexible. So if you look at this query in the middle, the DFS represents the distributed file system. That is known as internally known as a storage plugin instance, and that storage plugin instance is made modular. So you could actually extend those storage plugins to talk to other data stores if you want to. And based on this model, we've already seen communities from the MongoDB side, from the Cassandra side, trying to build storage plugins for Drill, so it's easy for them to query, use ANSI SQL to query Cassandra and Mongo data stores, right? So that, like I mentioned, so that storage plugin instance could be HBase or MapR DB. It could very well be the HCatalog server, and you're able to now do joins across all these different data sets using ANSI SQL semantics. The second part here is the workspace, where depending on what that data storage instance is, it could be a database or a subdirectory. And the third part, obviously, is the final file or the HBase table itself, right? So, or a MongoDB table for that matter. So this is built to be modular and flexible, so it's easy for you to extend and expand to other data sources. So the fourth concept is a unique security module that Drill comes with. So Drill does not rely on centrally stored security repositories, things like Apache Sentry, for instance, where you would store your RBAC information, your role-based access control information. Drill provides a different construct where you can actually put all of your security controls within the file system itself, where the data is residing, through what are known as Drill views. So drill views are essentially logical views of the table itself, and through those logical views, you should be able to provide the right level of ACLs or access controls for the different users within the organization. So, for instance, in this specific slide, we are talking about a raw file which has name, city, state, and some sensitive information about credit cards. There is the owner of that data. Now, that data needs to be given to different people within the organization. On the left-hand side, we've got a business analyst who actually doesn't need the credit card information. All he needs is a few specific columns within that data. So the owner would create a view of the original table and give ACLs for that specific view as read write only on those particular columns. Now there's another set of users out there for data scientists where they might need the credit card information as well, but you don't want to give away the real credit card information, so you would perhaps write a UDF, which is supported by Drill, a user-defined function. Then you would convert some of that real credit card information to a masked credit card information, and then give the view to the data scientist so he could go do his modeling and what he needs to do. Now, the beauty of this setup is that all of the security controls are within the file system itself, so there's one single admin who can control all of that. But the bigger point is that you could start doing ownership chaining across these different views. So let's say the data scientist now decides, I want to give a subset of my data to my own junior data scientist here who could work on a different model. So he would create a second view based on that original view, and then give read access only to that view for his junior data scientist. So that ownership chaining can continue all the way down as many levels as you want. So you would always know that, okay, these are all logical views, it's not duplicating the data. Second, there's only one owner to the data in terms of the raw data, and then everybody else has only view-based access to those data sets. So you could actually do joins across different views, and you can get all kinds of information out of the system without worrying too much about maintaining different security controls in a different repository somewhere, and worrying about how your end BI users are going to use it. There's also things like user impersonation and Linux pluggable authentication modules on the authentication side, so you know exactly who's logging into the system and who's running the query on the data set. So that's the security angle. And then finally, the fifth one is obviously the connectivity that we provide for the BI users. And we've worked with Simba for many years now. Our Hadoop distribution also has a Simba ODBC, JDBC drivers. For Drill, Simba has once again built a remarkable engine which has both Drill Explorer capabilities that Kyle will talk about, as well as the ODBC capability that allows end BI tools to connect seamlessly with Drill, and then the end user doesn't need to worry about what that engine is doing in the background. They'll get their results much faster than ever before, right? So that's those are the 5 top things that I want to talk about on the technical side. Let's look at some of the use cases that we are seeing in the market with the early adopters of Drill. So the very first thing that we've noticed is within a data lake environment, there's a lot of self-service data exploration that people want to do with big data. So if you look at this chart here, on the left-hand side, we've got raw data and some optimized data. So Drill is addressing that need really well for for those exploratory activities. Like I mentioned before, we have JSON data or CSV data. You should be able to go and query those data sets instantly. You could perhaps create a table in a Parquet format, convert those raw data into Parquet if you wanted to, or if you have data coming in as Parquet, you could use those data sets as well and do your exploration, right? Then once you've done your exploration, you can do whatever you need to do with the reporting on the reporting side. But then you could merge those data sets with your existing Hive data stores, your existing semi-structured or structured data coming from OLTP data sources, and do joins and merges across all these different data sets. So the Drill's unique value comes in being able to explore these data sets on the left-hand side. The rest of the engines on Hadoop, for instance, Hive and Impala, still require a centralized metastore, and they also provide, for instance, Impala and Spark SQL also provide interactive feeds for those data sets. But if you're looking at a data exploration, if you're looking at instant access, there's a telecom provider who's created a service for end users based on this concept where he would dump all of those cell tower information into a Hadoop platform and let his mobile operators come back and look at those data sets using existing BI tools like Tableau and Lumira and all those. Right, so that's a great use case that we are seeing as initial adoption starts to grow. The second one obviously is around the enterprise data hub concept when it comes to big data. So there's a lot of information stored in data warehouses. There's some being pulled into Hadoop for cost efficiencies purposes. But once you have data sitting on Hadoop, you would want your existing SQL users to go and look at that Hadoop data and do exploration on top of it or run SQL analysis on top of it. So you would get those interactive analytics done using Drill. Right. So in all of these cases, you would need a BI tool to get all of the visualization done, all the right tool sets done, all the right analytics done. So we see that SAP Lumira, for instance, you could use JSON. You could do JSON analytics, raw data exploration, data analytics. All of them go through the Drill engine, and then you could talk to different data sources. I mean, where there's files, there's directories, there's the Hive metastore or the HBase tables. Right. So this is where I'm going to stop, and I'm going to let Angela take over from here and talk about how SAP Lumira does a lot of great things for big data, and then you should be able to see how all of this in action when Kyle goes on. Over to you, Angela.
Great. Thanks a lot, Nitin. Hi, everyone. Thanks for having me and joining the webinar. My name is Angela Harvey, and I'm responsible for our big data strategy as it relates to analytics here at SAP. So really excited to talk to you about Lumira. Nitin brought up a really good case that, in the past, traditionally IT was defined by business users, and we've really seen a move that now it's really defined by the end user rather than having IT create business intelligence for their own use. End users want to be empowered themselves. So this is what brings us to SAP Lumira. They don't want to just access the data, but they want to merge it with other sources and enrich it and tell a story that's compelling to their end users. So Lumira really is an end user tool. So Lumira empowers business users in probably 4 key ways. The first one that it allows you to acquire data from various sources. Most end users don't even have SQL skills, let alone MapReduce skills or the ability to use tools like Drill. So Lumira is a great graphical interface that allows you to connect to these different data sources. We do leverage the Simba JDBC drivers so we can connect to pretty much any JDBC data source, and Kyle will be going through that in detail a little bit later. But it's, these new data sources are important, but it's also important to have the ability to merge them with traditional data sources. So we do have the prepare room where you can merge your data together and do enrichment as well. For example, you could add time hierarchies, like maybe you've got some sales data by the second or by the day, but a typical way you would report it would more be quarterly. So Lumira has the ability to do these types of calculations and add hierarchies and really enrich the data to get it in the format that you want to visualize it. The visualization is really simple, actually. It's just done through drag and drop charts, so you can easily pull them on, explore your data, get a good idea of the story you want to tell, and then if you want to really put it in a shareable format, we've also got a room that allows you to do infographics and similar. So if you're like me and you're not very artistic, it's a great way to bring in all the charting components in that you've created in Lumira, as well as add text and commentary around it, and it puts it in kind of a nice infographic format that you can share throughout your organization. There's a few ways that you can share it throughout the organization. So you can, if you're a current business objects user, we do integrate fully with that suite. We've also got Lumira Server for cloud, Lumira Server on-premise, and then a Lumira Server for Team Edition as well. So we've got a bunch of different sharing options at your disposal, and of course you can just export to PDF and do old-fashioned email if that works for you as well. So we've talked a little bit about the importance to the end user of being able to access the data themselves and do that exploration without relying on IT. I think one thing that's really important to call out is that it's important that you can trust your data. Nitin brought up security in that, and in large organizations, this kind of data governance is really important. We want to make sure that only the right people have access to the right information, but as an end user, I want to be able to rely on the fact that the information I'm accessing is correct and has gone through some sort of quality screen, because the worst thing would be if I put together a beautiful infographic and share it with my boss and the data completely conflicts with what she's she's found. So it's funny because I actually joined SAP in through the Business Objects acquisition in 2006. And the story we always talked about then was a single version of the truth. And then we've seen the emergence, because we really touted the universe and kind of this control and governance by IT. But we've seen more and more of our customers have these kind of analytical tools mushroom throughout their organizations without really tying into IT. And it's created these data silos again. So it's interesting that, 9 years later, we're back to the conversation of a single version of the truth, although now we kind of coin it trusted data discovery. So we mean that in a few ways. For BI administrators, there's really an enterprise readiness. So the ability to deploy Lumira in your existing managed environment. So you've got lifecycle management, administration, monitoring, and then the government piece as well. So the ability to control who can do what with what information and that kind of authorization, as well as auditing. So the ability to track what's been done to the data. So we are seeing this trusted data discovery as really key. You have to empower the end user, but you have to protect your data as well. So with that, it's one thing to talk about Lumira, but I think it's really better shown in action. So I'm going to pass it to Kyle Porter, who's going to go through a demo of how you use the Simba drivers to really connect Drill to Lumira seamlessly for some real-life use cases.
Thank you, Angela. So I'm Kyle Porter. I'm a senior sales engineer here at Simba Technologies. And I'm going to run through connecting to Drill, doing a little exploration of data, and showing that off in SAP Lumira. So the scenario we want to consider today is that we have a network set up with a bunch of computers in our enterprise, and some of the users have complained about slowness at some intermittent times. So what I've done is I've taken a Wireshark trace of all of the packet traffic going back and forth on this network, and I've put that into Drill that we're going to explore going forward. So I already have Drill set up, and I have the data put into HDFS on Drill as a CSV file. I also have the the MapR ODBC driver for Drill that Simba developed installed. And the first thing we want to do is we want to go to the ODBC data source administrator, and we'll configure this to create a DSN. For those of you who don't know, a DSN is essentially a set of settings that have been saved so that when we go and use the driver, all we have to do is select the CSN and go. So I put in my host here, my port. I selected my authentication type, which is none for now, but you probably have authentication set up. And we can go and we can actually look at our data through the Drill Explorer. And this is where we actually do the exploration of our unstructured data that Nitin was talking about. By default on the left-hand side, it shows what is actually on our HDFS in Drill. And we can drill in here, pardon the pun, and you'll see that these are all the directories on my Drill server. And if we just click on one of these, you can see it's a Parquet file, and look at a live preview of the data. I have a CSV file, as I said. I also have a JSON file, which we can just preview. We're going to actually look at the TCP dump from Wireshark of the packet traffic. So you can see here that it's pulled out all the columns, and it's also showing the metadata for each of the columns. It says, there's 7 columns here. It thinks they're all bar chart right now, and here's the preview of it. So before we can actually do any analysis on this, we need to create a view. Any of the data here isn't actually visible until we create that view. So if we switch to the SQL tab, the Drill Explorer has created this SQL query, which it thinks represents your view. And you can just preview that. There's a few things that we want to change, though. One of the things is we want to give these columns proper headers, and we want to get rid of this header line from the CSV file. So I've already put together a SQL query which will do that for us. What this is doing is it's actually going to convert this second column from a string into an actual timestamp. And it's going to convert this sixth column into an integer. We'll ignore our header line, and we're just going to limit it to 10. So if we do a preview on that, you can see that we have a nicely formatted result set now. So I'll take away my limit, and we can create a view from that. So you select the schema you want your view to be visible in, give it a name. I'm going to overwrite this since I've already created this view before, but if you didn't, you wouldn't have that there, and we'll save it. And here you can see the actual SQL that was executed in Drill to create our view, and that it was successful. So now that we're done that, we can close. And that's literally how easy it is to create a SQL table view on some unstructured data. Now that we're done with that, we can close our configuration. And now we can do some visualization within SAP Lumira. To do that, I'm using the ODBC driver. You can also use the JDBC driver directly. But since I'm using the ODBC driver, one of the things you want to do is go to your start menu, and this is installed with the driver, and click on the Install SAP Lumira extension. And that will install the extension into SAP Lumira so you can use Drill. So here's SAP Lumira, and if we go create new document, we'll go to external data source, and next, and choose the MapR extension. Go next. Here it'll ask us to select what we want to connect to. So you can either connect directly to the driver, or we can use the DSN that we just set up. So we'll select our DSN. You can either query directly on a table, and if we scroll down, we can see there's our sensor data view that we created, or we can enter a query. So I'm going to use a query. The reason I'm doing that is I'm taking all of the columns that we defined in our view, but I'm also going to add an extra column here, and this is so that I can detect some errors in our data. So this is info column, which contains information about each packet. What I'm going to do here is this SQL statement here is just saying if there was an error, return 1, otherwise return 0. And we'll call that our is retransmission column. So we'll go OK. And Lumira will then execute that SQL query against Drill using the Simba ODBC driver and pull back a result. And here's the preview of our result. You can see a number timestamp our is retransmission column. So let's create our data set in Lumira so that we can do some analysis on it. So that right now this is executing the query. It's gone over to Drill. It's run through its execution engine. It's put that against the CSV file and retransmitted the 90-odd or 100,000-odd rows back to us. This is your first time seeing SAP Lumira. Here's the report view for our active visualization. This down here is our storyboard for all of our visualizations we've created. These are the different types of visualizations that we can use and the different modifications we can do for our active visualization. And on the left-hand side, this is where all of our columns show up. Any numeric columns show up as measures, and any non-numeric columns show up as dimensions. So one of the first things we'll do is we'll just change this number from sum to account so we can see how many packets were done. We can throw that on there, and we can throw the protocol on. So I'm not a network engineer, so I actually thought that TCP and UDP would be the dominant protocols shown here. But if you select them, you can actually see TCP is a very small slice, and UDP is a very small slice of this pie. Actually, the dominant one is LLMNR, and I did look up on what this actually meant, but it was too long and I don't remember, so you network engineers will probably be laughing at me. But yeah, this is the dominant protocol followed by MBNF and SFTP. So that's just kind of a little curiosity. What we're really looking for is trying to find out where that network problem is from our packet traces. So one of the first things I might want to do is look at source and the number of packets being sent by source. So we'll just change this over to a stacked column. And I'm going to duplicate this because I'm also going to look at a different view of this data. But if we sort this, you can see that there actually is, a spike over here. So we can filter over to those, and we can filter that by protocol. Although these top ones are sending more data than the majority of the computers in our network, if you think about servers, then this actually doesn't seem out of the ordinary. There's not one protocol that's being dominant on the top computers, although there are some odd things like this computer sends a lot of IIP and this one sends a lot of LLMNR without any other traffic. So we can also switch this up and look at it by destination. Similarly, we'll sort. And this one looks even more skewed than the previous one. There's only about 10 or 11 computers here. And if we sort by protocol again, this computer looks a little bit suspicious because it's got another 10,000 packets compared to anything else, although it's all MBNS. So this may also be represented by servers on our network. Now, because I'm kind of a nerd, there's also a different view of this data you can look at, which I thought was really cool, which is a 3D view. So our computers are on this axis, and the protocols are on this axis. And you can actually take this and you can rotate this view around to give you a really easy view of what is actually going on in your network and which computers are sending which protocols. But as I said, this is just looking at the number of packets sent, which can be kind of easily explained by just servers who are typically more powerful machines that many of the computers on our network will talk to. So if we just want to look at why there might be problems, we probably want to look at our is transmission problems. So if we throw our is transmission, and we'll look at it by source, this looks a little bit more useful. You can see that there's this up here that has a lot of errors compared to everything else. But there's a lot of empty entries here. So what we'll do is we'll put a filter on is transmission. So we only want ones where there's errors, represented by 1. And here we have a much more interesting looking graph, which we can also sort by protocol. I'll put this as a stacked bar chart. You can see that this computer, by and large, had the most number of send transmissions, all TCP. And then this computer is also a little bit suspicious. So we can duplicate this as well and look at it by, instead of source, we want to look at it by destination. And once again, we have one computer that sticks out. So the interesting thing is, okay, we know these computers, this one has a problem receiving, and this computer here has a problem sending. So I wonder if they're correlated. So we can figure that out by looking at a heat map. We'll throw this transmission on here, and once again, we'll put a filter on because we only want to look at transmission errors. We'll throw destination in, and we'll put source in. And you can definitely see there are problems in the network, specifically with this computer sending to 10.1.1.11 on our computer. And there's also another small problem here. So there definitely is a problem, and we've kind of isolated it down to those two. Now we can also go and filter out to just this. And we'll make this a nice donut chart. So these are the computers that one specific problem is having. There's more problems sending data back and forth from this computer to other computers on our network. So we've really isolated the problems on our network for our network engineers to look at down to the network hops between those computers. So I started with just a CSV dump from Wireshark, capturing all of the traffic on our network. Was able to throw that into Drill and create a nice table on that, a nice structured view of that data, from which I could use SAP Lumira to easily visualize and pull out exactly where that problem was using the Simba ODBC drivers. And so that wraps up my demo. And I'm going to pass it back to Soph now.
Thanks, Kyle. You can see we've posted some nice resource links here. Thanks, Nitin, for putting this list together. You can kind of see where to go. We'll also make this webinar available online. It'll be online at simba.com in the next few days, and you can access this list from there as well if you're not able to write all these things down very quickly. But appreciate the list. Appreciate the help. I wanted to share a couple of quick questions with our panelists before we wrap up for good. Angela, the first question is really for you. And you talked about SAP Lumira, and the question is, can I use Drill with business objects?
That's a great question, yes. So with Drill, you can, basically our universes in the business objects universe can connect to Hadoop. So yes, you could leverage it through business objects universes or directly with Lumira, and Lumira completely integrates with business objects. So we've got a few different options for you there. If you're not using Lumira, you can go through the universes. If you are using Lumira, you can go through the universes or direct to Drill.
Thanks, Angela. Next question is either for Kyle or for Nitin. And it was a question about the SAP extension for Lumira. Actually, maybe this is for you, Angela, sorry. Is that included in the MapR distribution?
The extension for Lumira, I believe Kyle will be making it available.
Yeah, so actually the extension is available as part of the ODBC install. So when you install the driver, it's already available, and it will show up in your start menu, which I showed when I was demoing.
Great, thank you. All right, Nitin, maybe this one is for you. And I think this will be our last question here, and then we'll wrap. I should say, I know we didn't get to all of the questions. We will follow up with you with the questions you've asked individually. The question is, should all the data be present on HDFS while querying, or can it connect to Oracle or any RDBMSs at real time and provide computation?
So at this point in time, the answer is HDFS. But there is the work being done in the community to provide a JDBC connector to relational data sources. So within a few months, we anticipate connecting to other relational sources as well. But right now, if you download it, you should be able to connect only to HBase and Hadoop.
Got it. Thanks, Nitin. And with that, we'll wrap up. Appreciate all of your time today. Thank you for joining us for today's webinar. As I noted, we will have recordings of this webinar available on Simba.com and perhaps even MapR and SAP Lumira websites. Check with us, and we'll make sure that you can listen again to any part that you may have missed or share with colleagues. Thank you all. Appreciate your time today, and have a great rest of the day in whatever part of the world you're in.